can just burst. We're done with Unit 2. Except you gotta take that test. But I'm so excited. Who gets more excited than this guy? Nobody. Because I drink my Dunkin' Donuts coffee. It's all about product placement. And ooh, I like to place that product and drink it as much as possible. Oh my God, nailed another Dunkin' Donuts commercial. That brings my revenue made from Dunkin' Donuts up to nothing. They still haven't paid me for all this free advertisement they're getting. It's kind of embarrassing. Anyway, you guys have a test. As usual, if somehow I happen to make a mistake, which, because I'm bald and I drink way too much coffee, could happen, let me know. If you let me know and I make a mistake, you get bonus on your test. If you don't let me know, and you saw it, and you didn't say anything, that's not too smart. No, really, it's not. Anyway, let's get started. Oh, you haven't done the work yet? Oh, you just came to watch the bald guy perform? His mathematical magic? Like, that's gonna help you on tomorrow's test? No, don't think so. Not gonna help you. Get working on your own, students. It's gonna help you on the test. It really is. You should press pause. Try the problem. More importantly, if you're in my Google Classroom and you're one of my students, check your Google Classroom. The answers are there. I already have the answers. Match your answers up with my answers. If you didn't get the right answer, why don't you come watch the video? If you didn't even do this and you're sitting here copying, tomorrow's going to be a really tough test, and then I'm going to have to listen to you complain. Don't want that. Let's get started, though. Enough of the negativity. I know you're not doing that. So, squared means write it twice. So, 3 minus 7i times 3 minus 7i. If I double distribute those, I get 9. That's the 3 times the 3. And then the 3 times the negative 7 is negative 21. I figured I'd write really ginormous like some of you. And then negative 7 times 3 is negative 21i. And then negative 7 times negative 7 is positive 7. And I times I, positive 7. What am I doing? You thought you had a bonus point. I caught it. 49 I squared. Now these can be combined. Minus 42i. And then you, my friends, and not so many of my friends, have to remember you got something to do here. You got to know that I squared is the same as negative 1. It's one of those things you have to have memorized. So if that's true, then this is 49 times negative 1, which is minus 49. So my final answer is negative 40 minus 42i. I hope I got that one right. Oh my God. I jokes are the best. I think they are. I hope you do. I don't care what you... Whatever. Anyway, the cool thing about this is I can check to see if I got it right. Oh, I didn't start my calculator. When my calculator shows up eventually, I will check my answers. It's almost there. So... I had it up earlier, and then I had issues with my computer. So let's go into calculator mode. So parentheses, 3 minus 7i, parentheses squared. And this will tell me whether I'm right or wrong. Yes! I got it. You're not getting bonus points. So what we have to do here, because it's a radical equation, is get the weird thing alone. Kind of like me, down here in my creepy basement, with nobody around. All by myself. So I can sing when I want to, and I'm a really good singer. Yes, I am! Not really. That's why I teach math. Anyway, I gotta get the weird thing alone. There's the weird thing. We gotta get the weird thing alone. So, we're gonna subtract 5. And subtract 5. And I get the square root of x minus 8 equals 7. In order to get rid of a radical, I'm going to do its inverse operation, which is to square it. But if I square one side, I have to square the other. So I get x minus 8 equals 49. Add the 8 over, and I get x equals 57. Gee, I wonder if I'm right. I wonder if there's a way I could check my answers and be correct. I bet there is! Oh yes there is! The stove feature on the calculator. Let's do that. 57, control var x. Enter. Oh, forgot x. Off my screen. X. Enter. And then I type it in. Square root of x minus, have no idea, 8 whoosh, whoosh, plus 5 equals 12. That's 2 I got in a row. 2 I got in a row. You can't. Oh, what do we got here? On the set of axes provided, graph the function. Somehow the axes are not here. So I'm going to have to, I don't know what happened there. I'm going to pause and I'll be right back. Well, somehow I forgot to put that graph in there. I apologize about that one. So I got one in there. Not the greatest graph, but we're going to use it anyway. All right, so I've got to graph this thing right here. Now, I can do one of two things. I can just do it. This is going to be the normal curve, but we're going to move it to the right 2. Oh, wait, this is a cube root. Normally a cube root. So we're going to go to the right 2 cube root. 1, 2. And we're not going up or down at all. So I go to the, no, there's only one number in the front here. I'm going to show you this way to do it and then the next way. So we're going to put in a 3, and I put in a 3, you go right 1, right. Oops. And then I'm going to go 1, 2, 3, 4 to the right and up. No, I got to go 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8 and up 2. So that would be the one to the right. And then I'm going to go to the left 1 and down 1. And I go left 8. That's out 6. 1, 2, 3, 4, 5, 6. Down 2. And that's what it should look like. Now what you could also do, very simply, is just go over to your graphing calculator. Go into graphing mode. Go into graphing mode. Type in the cube root of x minus 2. Hit enter. That's what it looks like. And then go to the table. Control T. What are nice values that I can plug in? Well, you'll notice the reason we pick -6 to 10 is because look at -6. It's such a nice number. -2. Then I go, the next nice number I could plug in is, ooh, look at that. -1. 2, 0. 3, 1. And then the next nice number will be 10. And there it is. I've graphed it. That's it. That's all I want. All right. Now, should you be able to do this without a graphing calculator? Absolutely. But wait a second. These are just I times I times I times I. What do we do with exponents when we multiply when the bases are the same? We add the exponents. 0 plus 1 plus, that's 3, that's 6. Well, what is I6? Well, you should be able to say I squared is I to the 1, I squared, I cubed, and I to the 4th. Now remember, every time you get back to 4, you're back to 1. Now remember, this is negative I. This is negative 1 over here. That's 1. And this is negative I down here. And this is just I. So 6 is 1, 2, 3, 4, 5, 6. The answer is -1. Now, can you test it on your calculator? Absolutely. I can test two things. I can test a couple things. I can test I raised to the 6th. But then I'm like, well, am I really right about I to the 6th? I don't even know. Maybe I don't want to do that. Maybe what I want to do is I raised to the 0, get out of that, times I. Now you could raise it to the 1. It's, that's the same as just I, right? And then times I squared times I cubed, -1. So lots of different ways. You should show work. You have to show some kind of work. That's it. All right, look what we can do here. So how does the graph of the 3 moving it compared to the parent. Remember, this is the parent function. So you got to remember your transformations, right? The 3 in front, this is a dilation of 3. What does this mean? This means we're going to have a translation right to. Remember, it's backwards. And on the outside, we're going to translation up 1. That's how it compares. Done. All right, cube roots. We're going to take the cube root of this. So you got to know your cube roots. 1, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. I probably can stop there, can't I? Because it's 64. Yay! So the cube root of 64. Now these got to write as groups of 3. So x cubed x, y cubed. All right. So I come through. The cube root of 64 is 4. The cube root of x cubed is x. The cube root of y cubed is y. This is 4x, y, cube roots of x. Now, if you don't put a cube here, like if you put a cube here, that's not a cube. That's not a cube root, that's a cube. You got to put the little cube root right here. Put that 3 right there. If you forget it, it's wrong. Alrighty then, the weird things alone, so we got to get rid of it. So in order to get rid of a square root, we are going to square both sides. And square both sides. So what I get here is 5x minus 6 equals x squared. You never want to have your x squared negative, so this stuff got to go over to the other side. So I end up with 0 equals x squared minus 5x plus 6. Now, we got some factoring to do. X and x. They have to multiply to 6 and add to 5. Don't put 6 in 1 like you're a monkey, because 6 minus 1 is 5. That really is awesome. But that would not be right. It's minus 3 and negative 2. Because those multiply to positive 6 and add up to negative 5. So my two answers are x equals 3 and x equals 2. But with all square roots, you have extraneous solutions. You might have to check them. I'll check them over here. 5 times 3 minus 6. That's 15 minus 6, which is the square root of 9. Oh, by the way, does that equal 3? Does that equal 3? Yes. 5 times 2 minus 6. Does that equal 2? 10 minus 6 is the square root of 4. Does that equal 2? Yes, they both work. They don't often work, but sometimes they do. Let me rewrite this one so it looks a little bit better. You have to get the weird thing alone. The 7 has to go. So we get divided by 7. Gone. So I get x to the 1/2 power equals 16 over 7. Now, in order to get rid of a rational exponent, you have to raise it to the reciprocal. In this case, my exponent is 1/2. The reciprocal would be 2 over 1. So we have to raise it to the 2 over 1, which is just really 2. So if I raise that side to 2, I have to raise this side to 2. So now I get x equals 16 squared is 256 over 7 squared, which is 49. No way that's right. Nope, not going to believe it. Don't believe it, can't believe it. Nope, oh, all right, I'll check it. 256 divided by 49, control var x. X. Enter. 7 times x raised to the 1 divided by 2 is, oh, look at that, it's 16. That's so weird. It's so weird. It works! Yay! Product. Product means multiplication. So you have to multiply. 1 plus I, 1 minus 2i. Now, before I go any further, there's a really good chance I'm going to have I squared in this problem. Because I'm multiplying. And anytime you have I squared, you have to remember that's equal to negative 1. Don't forget it. Huge. Don't forget it. All right, 1 times 1 is 1. 1 times negative 2 is negative 2i. I times 1 is plus I. I hope I get this right. Oh, the I jokes are just crazy awesome. Minus 2I squared. I hope I don't forget what that's equal to. Oh, God, I need a vacation. I squared is equal to negative 1. So what I have here is negative 2 times negative 1. So this is 1 minus I minus, negative makes a plus 2. So it looks like my answer is 3 minus I. And of course, that's an A plus BI form. So I'm going to come over and check it with my calculator. I got to do it. So it's 1, I think it was 1 plus I, right? I hope it is. 1 plus I, 1 minus 2I, 1 minus 2. I hope I get it right. Oh, 3 minus I. Yay, it's right. All right, here we go. Oh, my goodness. Oh, I do have graph paper this time, so that's good. I love you. Oh, wait. Square root of negative 1u. Shoot. Hi, kids. You weren't supposed to see that. Anyway, let's do this. So we're going to graph this. Right? We're going to graph this. So that's the line. It's got a y-intercept of 2. And a slope of negative 1. So and go this way. So all of those points. Now, I don't want to use all of those points. I only want to use the points that are less than 2. I only want to use the points that are less than 2. So what I'm going to come through is I'm going to erase all the points that are bigger than 2. Now, it also says less than 2. Notice it says just less than, not equal to. So I need to have an open circle here at x equals 2. See, this is x equals 2. And we're going to go less than that. All of those. So then I'm going to grab this thing. Now, this thing is going to move right to and up 3. Normally it would be, I'll do this one in orange. Normally it would be right here. But we're going to move to the right 2 and up 3. 1, 2, 3. And it doesn't have slopes, so we're going to go right 1, up 1. Right 4, up 2. Right 9. Can't really do that. It would be up in this area somewhere, right? So I'll go, and I just go. Now I just have to decide: do I put an open or closed circle at 2? In this case, I'm going to put a closed circle. Is it a function? Oh yeah, it is. Is it 1-to-1? Oh no, it ain't. Fails the vertical line. Fails the horizontal line test. Right there. Fails it. I know. Average rate of change. When you see average rate of change, anytime you see this, average rate of change. Gee, I wonder if it's going to come up on the test. Oh yeah, it is. You have to remember. Oh yeah, that's f of x2 minus f of x1 all over x2 minus x1. Ba-bam! You got some work to do. Let's figure out what f2 is. Let's figure out what f of x2 is. x1, x2. Oh my gosh, I gave you 0? How nice am I? Let's do 12. 12 plus 4 minus 3. Well, that's the square root of 16 minus 3. The square root of 16 is 4. 4 minus 3 is 1. Now let's figure out what f of 0 is. 0 plus 4 minus 3, which is equal to the square root of 4 minus 3, which is equal to negative 1. Notice what would happen if I didn't use parentheses here. Some little poor slap that, I don't know what I'm going to say, would do 1 minus, oh yeah, negative 1, 1 minus negative 1 all over. And then you'd forget that you have a double negative here. Use parentheses. As Mrs. Newman likes to say, parentheses, Patrice! I don't have as annoying a voice as she does, though. Hers is much more annoying. And then 12 minus 0. So in the numerator, it's actually 2 over 12. You can leave it like that. If you'd like to give it to me as 1/6, I'm okay with that. Moving on. So we got multiplication. We've got some double distributing. We're going to multiply this times this. That's 12 square roots of 9. Yes, I know the square root of 9 is 3. Plus 8 square roots of 6. Minus 18 square roots of 6. Minus 12 square roots of 4. Now you got to go through and simplify this. This is the square root of 9, which is 3. The square root of 4, which is 2. I can't do anything with the square root of 6's, but these can be combined. So these give me negative 10 square roots of 6. And over here, I've got 36. And over here, I've got minus 24. 36 minus 24, that would be 12. Gee, I wonder if there's a way I can tell if I got the right answer, Mr. Krause. Why, Mr. Krause, there is! See, I'm down here talking to myself. Somebody's going crazy. All right, so let's take our calculator out. Boom, boom, boom. Where? That's not our calculator. Calculator. There it is. It's probably right here. Let's do this. Right there. Oh, yeah, that's perfect. We're right there. So I'm going to do parentheses 4. Now, this is going to take a few minutes. It's kind of a pain in the neck. Square roots of 3 minus 6 square roots of 2 parenthesis 3 square roots of 3 plus 2 square roots of, oops, what the hell just happened? All right, let me get out of that. Plus 2 square roots of 2. It's not really working that well. 2. Now, notice how I kind of didn't put it in. It kind of went, I just triple check to make sure I got it in there right. 4 square roots of 3 minus 6 square roots of 2, parentheses, 3 square roots of 3 plus 2, and hit enter. And I get that weird stuff. And I said oh, what? Oh, crap. All right, so I forgot I'm using a different calculator. Yours won't give it to you like this. Yours won't do this. It's not allowed to do it. You're not allowed to use this. You're not allowed to use this calculator on the Regents exam. So mine gives it to me as 12 minus 10 square roots of 6, which is the right answer. What's going to happen on your calculator is, let's see, menu, actions, number, approximate to decimal, convert to decimal. So yours will look like this, negative 12 minus, or 0.4949. And then you'll say, okay, what is 12 minus 10 square roots, escape, 10 square roots of 6, enter. And you'll have to see that the decimals match. I'm sorry, I forgot I'm using the others. I'm using the fancier calculator. But you'll end up with a decimal. Check your decimals, make sure they match. All right, sorry about that. Okay, so here's average rate of change again. Average rate of change is slope. We have a formula for average rate of change. Let me change out of this. We have a formula for that. And it's the subtracting of the y's over subtracting of the x's. So I've already got them. I want you to go from negative 3 to negative 1. There's negative 3. There's negative 1. So we're just going to use those values. 5.75. Parentheses, Patrice! God, that's annoying. 4.25. All over. So I did 5.75 minus 4.25. So it's negative 1 minus negative 3. No idea what this is. This is in the numerator, it's 1.5. All over 2. So it looks like it's 3/4. Or 0.75. 0.75 might be your answer. Let's see what the calculator says. So we're going to do control division. 5.75 minus 4.25, 4.25, all over. Now, I should have used parentheses, so this one I will be using them. Negative 1, parentheses, minus, parentheses, negative 3, parentheses, 0.75. You can also have 3/4. Moving on. Write this in simplest radical form. So I'm going to show you how to cheat on this one too. So we're going to go negative 2x square roots of. Now 72, that's the one we love to ask as math teachers because everybody picks 9 times 8. But 8 has a perfect square in it, so you can't use that one. Remember, it's 36 times 2. X. Now we're going to write them as groups of 2. X squared times x. Y to the 4th is fine. So let's go through. Square root of 36 is 6. Square root of x squared is x. Square root of y to the 4th is y squared. So now I just got to put it all together. Negative 12. X and x makes x squared. Y squared. Square roots of 2x. Now, you can check this one too. Now, this one's a little bit weirder to check, but you certainly can check it. It may turn out weird, so I'm going to do negative, I'm going to do 2.154 stow x. I always pick weird values, stow x. And then y, let's say y is 5.4, control bar x. Oh, y. We're going to make y this. Enter. So now I'm going to type in the original problem. The original problem was negative 2x square roots of 72x cubed. I have no idea how that happened. 72x cubed. Y to the 4th. Y to the 4th. Enter. Some dumb answer. There it is. Now I'm going to check my answer. Negative 12x squared. Negative 12x squared. Y squared. Square roots of 2x, I believe, right? Enter. Same dumb decimal, same answer. The settings are all messed up. Shoot. Make default. Yes, do default. Okay, there it is. There she goes. All right, what is this answer in simplest radical form? So, square root of 80. That's 16 times 5 plus 3 square roots of 9 times 5. Don't you dare give me like 3 square roots of 125. I will get very upset with you. Square root of 16 is 4, so this is 4 square roots of 5. Square root of 9 is 3, so that's 9 square roots of 5. 4 square roots of 5 plus 9 square roots of 5 is 13 square roots of 5. And yes, you could use your calculator to check that one as well. Perfect cubes. We need a perfect cube that goes into 32. Let's see. How about 8 times 4? Now we're going to write it as groups of 3. X to the 6 is okay. Y to the 4th is not. We need to write it as y cubed times y. Cube root of 8 is 2. The cube root of x to the 6 is x squared. The cube root of y cubed is y. So my answer is 2x squared y. Square roots of 4y. Were you hoping I'd keep it like that? Oh no, I made it. There it is. Cube roots. It should be cube roots, kids. There's your answer. All right, so this next one is not going to be easy. We're going to have some weird stuff going on. Maybe I need a break. Hold on. Okay, this one here it is. Got to get the weird thing alone. Don't forget, anytime you're going to solve radicals, think about me sitting in my basement all here by myself, get the weird thing alone. So we're going to subtract x. And we're going to subtract x. So I get the square root of x plus 1 is equal to 5 minus x. Now, to get rid of that square root, I got to square both sides. Notice I'm putting them in parentheses. Oh, gee, I wonder what parentheses squared means. Oh, yeah, that's right. I got to write it twice. 5 minus x. Squared means you're going to write it twice. Now, on this side, the square and the square root do each other in. We get x plus 1. On this side, we got to double distribute. 5 times 5 is 25. Minus 5x and minus 5x, that's minus 5x minus 5x. And negative x times negative x is positive x squared. Since my x squared is positive, I'm not moving it. All this stuff comes over here. But I'm going to write the x squared first. And let's see, I'm going to subtract x. So that's minus 10 minus 11x. And then this is minus 1, so that's going to be plus 24. All right, so I get 0 equals x and x minus 3 and minus 8. Those multiply to 24, add up to 11. So my two answers are x equals 3 and x equals 8. Oh, goody. Wait! Mr. Krause said we might get these things called extraneous solutions, and I have to check my answers. So we're going to do that. We're going to check our answers. So let's check them. 3 plus the square root of 3 plus 1. Does that equal 5? Well, this is 3 plus, this is 4. That's 2. 2 equals 5. Yes. 8 plus the square root of 8 plus 1. Does that equal 5? Square root of 8 plus 1 is 9. The square root of 9 is 3. 8 plus 3 is 11. 11 does not equal 5. It appears as if 8 doesn't work. But honestly, I would check using the calculator. I'm going to take 8. I'm going to stow it into x. Hit enter. And I'm going to type it in. 3 plus the square root of x plus 1. Enter. It's... Oh, oh no, it's 8 plus 1, not 3 plus 1. Oh, I don't even know what I'm talking about. Wait, the equation was x plus, so even though I put a 3 here, I should have put an x. So is x plus the square root of x plus 1, hit enter, and I get 11. There's my answer. 11 does not equal 5, so that's not the answer, only 3. Remember, you could always get extraneous solutions. Inverses. Find a of x given that this. It's the same process. We're going to write this as y equals. We're going to switch x and y. Now we're going to solve it. Now, in order to get rid of a cube root, we have to cube both sides. So I got to cube this side, which means I have to cube this side. So I get x cubed equals y plus 27. Bring that over. I get x cubed minus 27 is equal to y. So a of x is equal to x cubed minus 27. I'm going to check this sucker graphically. I'm not really sure if I'm right or not. So let's see what we look like. So we're going to go into new graph mode. And my original one was the cube root of x plus 27. So the cube root x plus 27. Enter. Well, that's kind of boring. Ah, there we go. That's a better look. Let's go into menu, window and zoom fit. It's probably a better one. Ah, there we go. That's better. That's better. That looks good. Now we're going to type in its inverse. Now its inverse was x cubed minus 27. X cubed minus 27. So we're going to go tab x cubed minus 27. I don't think I wrote that right. Tab. Why can't I get that tab? Oh, I'm not hitting tab. I'm hitting control. X cubed minus 27. Menu, window, zoom fit. I don't know. Looks like, I think I'm right. Maybe I'm wrong. Maybe you're going to find something out. So I'm going to try to show you why I know I'm right on this one. Remember, when you have an inverse, you really are switching the x and the y, correct? So the y and the x just flip. So if I go over to my graph mode, if I go over to graph, my calculator, and I look at this one, negative 26, 1. Negative 26, 1. That means on the other function, I should have 1, negative 26. So when I come down, there's 1, negative 26. Or here's one easy one. 3, 0. That means I should have 0, 3 on the other one. And here I have negative 0, negative 27, and so that one I should have negative 27, 0, negative 27, 0. So I switch the x and the y. It's a simple way to text. I know that one's kind of funky. Let's keep going. Let's move. Let's do it. Now. Okay, this is a square root function, but remember, this has got a negative, so it's coming down. So we're going to graph this baby. We're moving to the left 4, 1, 2, 3, 4. Down 2, 1, 2. We're going to put an open circle because it doesn't have an equal to. And we're going to the right 1, down 1. We're going to the right 4, down 2. We're going to the right 9, 4, 5, 6, 7, 8, 9, down 3. And we want to go, just keep going to the right. Now, if you don't believe me on that one, one of the things you can do is just come over to your graphing calculator, hit this, and then type it in. Negative square root of x plus 4 minus 2. Enter. Oops, somehow we didn't get the minus 2. Tab. Oops, minus 2 went on the inside. That's a big mistake. You got to make sure you get on the outside there. Oops. You got to make sure you get on the outside with that minus 2, hit enter. Notice it comes down, it goes down. Notice it goes through the point 0.04 as well. You can always go to the table, look at the table of values, right? What were the table of values? Negative 4, negative 2, negative 3, negative 3. Those are all points I plotted. 0, negative 4, that's this point right here. And then the last one was 5, negative 5, 5, negative 5. That's that point right there. Okay, and I graphed it going to the right. All right, going to the right because it was greater than 0. Wait a second, greater than 0? That means I'm not going to start here. I have to start at 0. That means I have to start here, which means I can't use this point and I can't use those because I can only go here. So greater than 0 would be going like that. Right? If I looked at this graph down here, I can only start at 0. I can only start at 0 and go to the right. And then this one, negative 5. 1, 2, 3, 4, 5. Negative 5. There's my y-intercept. And I'm going to go down 3 into the left one, to the right one. Can't go any more that way, so up 3 to the right one. Up 3 to the right one. Up 3 to the left one. To the left, to the left, to the left. But I only want to start, I don't even want to use this one because I only want to go to the left of 0. So that means I got to go like this. That's a weird one, kids. That's a weird one. Which interval has a greater average rate of change? 1 through 6 or 1 through 13? Justify your answer. So in this one, the denominator for, let's talk about this one, is going to be 6 minus 1. The denominator of this other one is going to be 13 minus 1. So I already know the denominators. That's 12 and that's 5. I just don't know what their numerators are. So we got to figure out what is it at 1. At 1, it's 1. Oh, wait, at 1. Yeah, no, at x equals 1, it's 0. At x equals 1, it's 0. So it doesn't matter which one I pick. When I choose 1, I get 0. So that's this second piece. At 1, right? 1, 0. And then at 6, 1, 2, 3, 4, 5, 6. What is that? That's crazy. Wait, 1, 2, 3, 4, 5, 6. Ah, here it is. I counted 6 from there. I meant to count 6 from here. So 6, 2. So at 6, it's 2. So that's 2 minus 0, which is 2, over 6 minus 1, which is 5. That's 2/5. Now I just got to figure out what 13 is. So that's 1, well, this is 6, 7, 8, 9, 10, 11, 12, 13. 13, it's all the way up to here. That's 1, 2, 3, 4. Excuse me. So that's 4. So I just used the y values. It's going from this point to this point, or this point to this point. And this one is 4 over. So this is really 1/3. Well, which is bigger? This is 0.4 and this is 0.3 repeating. So 1/6 has the greater AROC. Sorry, I'm out of room. My head's in the way. Has the greater average rate of change. So the speed of a tsunami, that's tsunami, can travel is modeled by this equation, where S is the speed in kilometers per hour and D is the average depth of the water in kilometers. Find S inverse. Okay. So I'm just going to write it as y equals 3, 5, 6 square roots of D. Switch S and D. So D is equal to 3, 5, 6 square roots of S. Now I got to solve for S. So first thing I do, get the weird thing alone. We're going to divide by 3, 5, 6. Same work, 3, 5, 6. So then I get D over 3, 5, 6 equals the square root of S. The only way to get rid of a square root is to square it. Yes, this seems rather odd. Square it. So I get D squared over, I have no idea, 3, 5, 6 squared. It's going to be a rather ginormous number. 126,736 is equal to S. So S inverse of X is equal to D squared over 1, 2, 6, 7, 3, 6. Are you confident? Did you get it right? It's true. There it is. Sketch the inverse. Now, if you're doing this on a sketch, you have to remember that inverses are just reflections over the line y equals x. Or we're just, so you can do it like this. Or I could just find some nice points. I'm going to find all the nice points. There's a nice point. 1, 2, 3, 4, 5, negative 5, 0, negative 4, 1, One, 2, 3, 4, 3. And looks like we got this one right here. 10. 1, 2, 3, 4. So all I got to do is graph. I'll do it in orange. The reciprocal. So 0, negative 5. 0. 1, 2, 3, 4, 5. That point. 1, negative 4. That point. 1, 2, 3, 4. 1, 2, 3. 3, 4. That point. And the last one, I'm not going to get. So 4, 10, 4, and then 10 is up here. But the reflection is, or looks like, that. And do those look like they're reflections over the line y equals x? Sure do. Sure enough. Moving on, children. We only got three problems left, right? I think we have 3 problems left. Perform the indicated operation. So you can't just add these up. You got to simplify. 4 times 6 is 24. Square root of 4 is 2. So this is 4 square root of 6. Now you got to take 96. So 3, 16 times 6. What's the square root of 16? 4. 12 square root of 6. So my final answer is 16 square root of 6. What does squared mean? Squared means write it twice. So it's pi minus the square root of 3 times pi minus the square root of 3. All right. Pi times pi is pi squared. Pi times negative 3 is negative pi square roots of 3. Pi times negative 3 square root of 3 is negative pi square root of 3. And then I'm getting kind of tired of this one, so we're just going to do it. The square root of 3 times the square root of 3 is 3. It's negative times negative, so it's positive 3. So my answer is pi squared minus 2 pi square root of 3, because these can be combined. There's minus 1 and minus 1 make minus 2, plus 3. All All right, we're on the last one. I to the 34th. You got to show your work. You can't just type in your calculator. I squared. I to the 4th. I cubed. Now I'm going to rewrite this as I to the 32nd times I squared. Why 32nd? Because that's a multiple of 4, and I know that anything that's a multiple of 4 is equal to 1. Remember, this is negative I, and this is negative 1. So this is really just 1 times negative 1, which is really just negative 1. Now, of course, I could type in my calculator. I to the 34th. Negative 1. But you have to show a little bit of work. All right, kid, there is a review homework assignment as well. This video will be posted next. It's just more practice, and I guarantee you have to do both in order to do well on tomorrow's test. Good luck, children. Hit the subscribe button. Hit the like button. Tell me how much you love my commercials. Maybe Dunkin' Donuts will give me $1, and I can get a free cup of coffee. I don't need any more coffee. Goodbye, kids.